Hello Charles Angels and welcome to another tutorial. Today we're going to be building a basic Tetris game. Lately I have been inspired by the 999 in 1 game. So if you grew up in the 80s or the 90s, the 999 in 1 game was very popular, and it had one of the games inside was Tetris. There was also the car racing, something inspired by alien invasion. So yeah, I've been inspired a lot by that 9991 game. So today we're going to be building a very basic Tetris game, nothing too fanciful. You're going to be able to move the shapes. There is no restart button, nothing too fanciful, just something basic, something I believe that you'll be able to expand on your own at the end of this tutorial. So yeah, if you're not yet subscribed, please do subscribe, because we are going to be building more awesome videos like this, and I would love you to be a part of it. Yeah, so let's hop on the code. Let's just hop into this. Now I'm in my VS Code and I have created a folder called Tetris Y. In this folder is where we're going to be working or doing what we want to do. Okay, so I'm going to create a new terminal here, and I'm going to say, I'm going to say npm create void full stop, no space full stop. And what I'm essentially saying is that I want to create the void bundle. I want it to be bundled inside this folder. Okay, so I'm going to choose vanilla. I'm choosing JavaScript, and yeah, and now I'm just going to run npm install. This is going to take a while, and I'm going to meet you in future after this runs. Our packages are finished installing, so let's just hop into what we are going to do. In our source folder, okay, let me just go and say npm not install run dev. Okay, so our server is running on localhost 51. What's this? This means, so let's say localhost, yeah. So this is what we have initially, and this is coming from our main.js file, all these. So let's just remove everything in here and save. If we go back, we can see that this is what we have. Okay, now I'm going to go into the index.html file, which is like the root of our application, and I'm going to create a couple of divs inside with the class single box. So that's going to be div.singleBox dash box. Okay, so I'm going to replicate this about, let's say, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good, fantastic. Okay, then we will go to our style.css. So in our style.css, we're going to just remove everything. I'll just remove everything, and we're just going to do basic styling. First, we're going to style the app itself, that is this one. So that's pound app. So I'm going to say display grid. Then it's going to be grid template columns. So it's going to be repeat 10, 50 pixels. So instead of 10, let's make it 4. Yeah. Okay. In case you don't know grid or you haven't worked with grid before, I have a tutorial. There's going to be a description below, or a card should pop up right now. Okay, after that, I'm going to style the single box. So that's a class. So dot single box, which is going to be height 50 pixels, width 50 pixels, and border is going to be 1 pixel, solid, but black. Save. Okay, so let's see what we have. Okay, so you can see we're beginning to form the layout of what we have currently. So in order to have a shape on the screen or on the board, what we're going to do is we're going to style one of these, or let's say 2 of this. Let's just style the last one, and we put field. So we're going to we're adding another class, so the class is just going to be field. And then if we come back here and we say dot single box dot field, that is if the single box class also has another class called field. So we're going to say background color, and that's going to be, instead of black, I just want to use a dark color, so it's just going to be 213547. Save. So if we go back, this is what it looks like. You could add, so if we, let's say, style this one to be filled, if we go back, you can see. So this is what we use. It's that class that we use in forming the shape. I'm sure you can begin to picture how this works. Now we're going to hop on the JavaScript side of things. So in our main.js file, we're going to bring in the main app. So the app, yeah. That's just going to be const main app is equal to document dot get elements by ID app, and after bringing in that, the first thing we want to do is we want to create a board. So I can so essentially instead of hard coding it like this, we want to use JavaScript to create it. So we're going to create a board. So the board is going to be an array, and the array is going to be filled with strings. So this is going to be a string. Let's just bring in empty strings. So that yeah, 4, yes. So let's duplicate this. So we have this. So you can see it looks like a grid that we already have. Okay, so after this, we're going to have we're going to create a function called initialize game. So the initialize game, in the beginning, it doesn't look like it's doing much, but when everything has come together, then you understand why we're just initializing the game. So essentially, maybe instead of calling it initialize game, we'll call it initialize the board, but I'm just calling it initialize game. So it's essentially just initializing the board for us. So I'm calling it initialize game. Okay, that how to spell it? No, that's yeah, game. So essentially, we're using this to initialize the board, something like that. So first, we want to clear out the main app. So that's going to be dot inner HTML is equal to an empty string. So we're clearing out everything. Then the next thing is we want to use the board to create the boxes. So So that's going to be board dot for each right. Then we're going to say const div lm equals to document dot create element div. Then we're going to say div lm dot class list dot add single box. Then main app dot append child div lm. Okay. Yeah, so let me call this outside and let's see what's now on the screen. So refresh. So you can see now this is, so we've used the board this to create this. Okay, so the next thing we want to do is we want to fill, let's imagine how the board will be filled. Remember when we started in the HTML we had this field, right? So let's just quickly work on that. So how we're going to achieve that is any board, any box that we want to fill, we're going to put a dot in it. So if I want to fill the first box, I'll put a dot. So back inside this loop, this for each, we're going to say if okay, so just bring this item, because each time we're looping we're going through each of this string. So if item is equal to a dot, that is if there's a dot inside, then we want to add the class list. We want to add the class list. We want to add a class to this particular an additional class to this particular element. So that's going to be div lm dot class list dot add field. Save. So if we go back, now the first one is filled. So if we want to form the classic cube, all we could do is put a dot here, put another one here, and another one here. So if we go back, you can see now we have that classic cube already formed. At the moment, we are hard coding the cube, but that's not what we want. We want a situation where the cube will be printed on the board. Okay, to do that, right, we are going to create an object. So that's going to be const. We're going to call this object shape or shapes, right? Then we're going to put a cube as a property here, and this is going to take in coordinates. I just call them coordinates. So let's start with 0, 1, 4, 5. So this is going to create a cube. So if you don't understand what I just did here, let's go back. So you can see here arrays start from 0. The index of an array start from 0. So this is 0, 1, 2, 3, 4, 5. So this is 0, 1, 4, 5. Okay, right. Then we're going to create another variable. We're going to call this shape picker, and this shape picker is going to have the names of all the shapes that we have. So I'm going to call this cube, right? All right, next I'm going to create not const let. So this is going to be called the shape index. And we're going to put 0. No, not put 0. All right, so this name is going to be used to, this cube is going to be used to pick this eventually. And this shape index is going to be used to pick the cube that will be used to pick this. I hope I'm making sense. Then next we're going to have let shape, present shape, not shape, okay, is equal to, so I'm going to say shapes, all right, then I'm going to say shape picker, then let's start with 0. So now if we look at this and say just this, shape picker 0 is going to be cube. So this cube is in shapes, which is eventually picking this. Then we're going to spread this out. Right. So just if you're confused, just console log this first. Then, this, what I did is this. Get, that's kind of what is happening. Yeah, and I'm spreading it out because this is an array. Okay, and instead of hard coding the 0, I'm just going to put shape index. All right. So this picks the shape for us. Now after picking the shape, the next thing we want to do is print out the shape on the board. We want to fill the board with the shape that we formed. Okay, so in order to do that, I'm going to create another function. I'm going to call this function fill board. So first we are going to say const all boxes is equal to document dot query selector all single box dot single box. Next, I'm going to say present shape dot for each so here I'm going to say position. So this is going to be the position because remember 0 1 4 5, we might call it coordinates too if you want, and it's fine. So board position equal to dot. So essentially what we are doing is that we are, remember, if it's empty, the shape isn't formed, but if we put a dot there, then the shape begins to get there. All right, next we're going to say board dot for each and then we're going to say all boxes. Did I say box? Sorry, it's supposed to be S. All boxes. Then I'm going to say item, then index. Right. For now, we don't need this. So we'll just put this. So we're going to say index dot class list dot add field. So I'm going to first remove this here. So you guys can see what it looks like. So remember now it's empty. If we go back, and then we call this sorry, no, here. What has happened? Oh, my bad. Sorry. Okay, let's bring back the item here. So we're going to say if item is equal to dot, that is if there is a dot, this dot is there, then we want to fill it. My bad. Okay, save. So if we go back, now it has been formed. Yeah, so if we change the shape to something else, let's say for example we put 6 here, that would also reflect. So if this isn't making sense to you, let's hard code it a bit. So we'll just say board, let's say 0, let's start with 0 equal to this, save. If we go back, you can see the first one is imprinted, and like that, yeah. Okay, so now let's put an else condition here. We're going to say else we want to remove the field. So I'm just going to paste this here and remove it. So if there is no dot, we want to clear that. So yeah, that is how we imprint on the board. So that's how we print on the board. That's how we fill the board with the shape. So the next thing we're going to be working on is moving the shape downwards, and I'm sure this is the part that everybody's looking forward to. In order to make the shape move down, we are going to be utilizing set timeout. Sorry, not set timeout. We're going to be utilizing set interval. But before we make use of set interval, we're first going to create a function, and that function is we're just simply going to call the function move shape to the next level. Yeah, I know, very, very original. So function move shape to next level. All right, so what we want to do is we are first going to clear the previous line. So we're first going to make sure that on the board, that present line we are on is cleared. Instead of, did I say previous? The present line, we clear it first before filling the next line. All right, so we are going to clean present line. Sorry. So we're going to say present shape dot for each. I'm going to say position like we have been using before, and this is going to be board position equal to an empty space. Right, so we're going to first clean the line that we are on. So if this runs, nothing will be on the board, right? So the next thing we want to do is to move it to the next line. Yeah, so I'll just call this continue to the next line. So this is going to be present shape is equal to, so we're going to write back into present shape. That's present shape is equal to present shape dot map item, and then we are going to remember map returns an array. So what we want to return back into present shape is an array, because present shape is currently an array. Now I'm going to say item plus 4, which is currently our grid width. We will soon change this. So let me just put a note here so that we'll change that in future. We're going to change this, change the 4 to a grid width. So I'm just going to say change 4 to grid width. So instead of a 4 hard coding the 4, we're going to change it to a grid width in future. So this is what is going to bring it down. So next we're going to bring in a set interval dot set timeout, set interval, and that's our callback function, and we're going to call this every 1 second. So this will be called every 1 second, and then if we go back and this refreshes, okay, sorry. So after this we are now going to call fieldboard. Sorry, let's remove fieldboard from here. Okay, so this would move to the next level, and this fieldboard would paint the body again. I think I need to add more lines so that this increases, so we enjoy it's changing. So let's go back. So it refreshes, it starts, moves down, moves down, moves down. All right, yay. And it's going to break obviously, but at least we've achieved it moving down. So if you didn't get what happened, is that this moves it to the next line, and then this paints this. Remember this, it will check for the present shape. What's the present shape at the moment? If the present shape has changed position, it then paints it back. All right, so yeah, that's for that. At the moment, whenever the shape goes down, it passes the board. That's not what we want, because that would break our code obviously. So what we want to do is that whenever the shape gets to the last part of the board, it should just stay there, and that's what we want to achieve at the moment. Okay, in order to do that, we need to bring in a couple of variables, and the first variable we're going to bring in, we're going to type is const grid width. So that's going to be 4. So we're just following this hard-coded board. Right now it's 4. Okay, so next is going to be const grid height, and the grid height is 6, because if you look at the board it's 6. Okay, this is very important because this is going to help work on every other thing for the app. So let's remove this, and then we're going to make this grid width. Good, perfect. Okay, so we're going to create an array. We're going to call this array last board line. Okay, so this last board line is going to contain it's going to contain the index of this. So normally we can hard code this and just say 20, 21, 22, 23, but that's not good. That's not good enough, because if the height and the width of this board changes, then something is wrong. So we don't want to hard code that. It's possible for us to hard code it like that. What we eventually want to achieve is have 20, 21, 22, 23, but we need to programmatically do that. Okay, so where we're going to do that is inside initialize game. So inside initialize game, we are going to say for let I equal to 0, while I is less than grid width I plus plus. Okay, so we're going to say last board line dot push. So we're going to say grid height times grid width minus grid width minus I. Okay, I know this could be a bit confusing. Okay, let me put this in another line. So I'm just going to say total board length. Okay, so this is going to be this. So I'm just going to cut this out and I'll put this here. Then I'll say total board length is going to be grid width minus 1. Okay, so what are we trying to, what was this here? So let's go back. So if 6 times 4 is 24, in the beginning 4 minus I, which is 0, that's going to be 20 minus 4, that's going to be 24 minus 4, which is going to give us 20. So if you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That gives us the first one, right? So if we go and see, let's imagine our I has moved to 1. So that's going to be 4 minus 1, right? That's going to be 3. That's going to be 24 minus 3, which is going to give us 21. This is 20. Obviously, this is going to give us 21, and so on and so forth. That is what we've achieved. That is what we use to get this last board line rather than hard coding it here. Okay, so with that being done, we now have back to our move shape to the next level. We have to check if we are at the last part of the board. Okay, so in order to do that, let's create a variable. The variable is going to be let is at end equal to false. Right. This is going to determine if the shape should move back to the top. Okay. So after we've cleared the line, the next thing we want to do is we want to check if the shape is on the last line. Okay, in order to do that, we're going to say present shape. No. Shape dot for each. Why are my hands moving fast? So we're going to say position. You guessed right, of course. We're going to do position. And then we're going to say if last board line dot includes position, then we're going to say is at end is equal to true. Okay, let's step back a bit and let's digress a bit and explain what's happening here. So now last board line at the moment contains contains 20, 21, 22, 23, right? So now what we're doing is we are looping through present shape. So present shape could be it will contain 4 numbers, right? It will contain 4 numbers, but we are going to be iterating through each of them. So let's say, for example, we have 0 we have 0, 1, 4, 5. We're going to iterate through it and then check is 0 in last bloodline? No. Is 4? Is 2 in last bloodline? No. Is 4 in last bloodline? Like that. Once it detects that one of the numbers is in last bloodline, I think I keep saying last bloodline. If it's in last bloodline, then it means that we've gotten to the end of that particular side. So I want this to make sense to us so that we're not just coding. So what I'm going to do here is that I'm going to console log the present shape, and then we're going to console log the last board line. Okay, let's go back to Chrome. Okay, So now we can take a look at it before it eventually breaks. Okay, it has broken and we're not concerned. So in the beginning, you can see we have 0145 and the board is 20, 21, 22, 23. Okay, then next we have 4589. None of that number is here. Then we have 8, 9, 12, 13. None of that number is here. Then we have 12, 13, 16, 17. None of that number is here. Then we have 16, 17, 20, 21. Now, if we look at the last board line, we can see we have 20, 21, 22, 23. So we have two of those numbers there, which means that this shape is at the end of the board. Yeah, I hope that makes sense. Okay. Yeah, so that's the explanation for what we are doing here. Then we now have to give another statement here. We're not going to check. Okay, so what happens when we are at the end of the line, right? What happens when we're at the end of the line? So if is at end, we're going to say set okay, no, okay, let's create a function first, because I wanted to type the function first, then I just realized it's better to just create the function first. So what we're going to create, we're going to create a function. We're going to say function is called set shape to board. So essentially what this is doing is this this makes the shape have a permanent stay on the board. You know, previously every time the shape is going down, we are clearing it. So once it gets here, we just give it a permanent space on the board. This makes the shape permanent on the board. Okay, so how do we do that? We're going to say shape. Okay, so we're going to pass the shape here. So that's going to be shape. We're going to say shape dot for each. So I'm going to say item, or of course, let's say position. I think since we have been doing position all through, so we're going to say board, then position. Remember, the position is a number. The shape is going to have a number in it. Okay, position is equal to dot. So remember, when we paint the board again with fill board, with this fill board over here, since this has a dot, it's going to just imprint that shape right there. So that's what makes it permanent. Okay, so what we're going to do here is, if we are at the end, we're not going to set shape to board, and then we're going to say present shape. We're passing the present shape. If we are not at the end of the board, then we'll continue to the next line. So we just move this upward. So how I do that in Windows is Alt up. So that would just move it. So yeah, that does that for us. So okay, now we need to ensure that we go back to the top. Remember, oh, I wrote that time. So we need to make sure that we go back to the top, right? So how do we do that? We are going to create another function. It's going to be called random shape picker. Okay, so what this random shape picker will do is it will pick a shape. Okay, we may not even need to create that function yet, but what we could do is we could just say present shape is, let's hard code this. So we'll just say present shape. Okay, let me just copy all this first. So let's hard code things first, right? to imitate like we're going to the top, right? So so that's going to be shapes. So okay, so now what is happening is that present shape will return back to its default because shape index is still 0, right? We haven't created more shapes. So what happens is that this kind of takes the present shape back to the top. Okay, we'll see that in action. So let me save, and okay, so you can see starts, it goes down, it goes down, goes down, starts again, comes down, goes down again, imprint, starts again, goes down. Yeah, it keeps going down. Yeah. So okay, let me close this. So with this, we can see that the shape is coming down. I know, this is fantastic. Woo! This is like a really major milestone. Okay, so of course, what's happening now is that it's passing through the shape. That's not what we want. We want a situation where it will stack on each other, right? That's what we want to do. We want it to stack on each other, right? That's what we want it to do. Now, ensuring that the the shape stacks on each other is quite straightforward. It isn't so complicated. Okay, so all we have to do is just modify this if statement a bit. Okay, so there's a bit of maths going on, but I'll explain it. So we have board. So if board, then position plus grid width is equal to a dot. So we're going to say or. So if there is okay, so let me explain. So presently, let's imagine that the position is, let's say, the position is, this would be 3, 4, 5, 6, 7, 8. Okay, so let's say the position is presently 4. This is 4, right? So let's imagine this is 4, and then the next box, like the box that is already imprinted on the screen, is at 8. So what we're trying to do is that, okay, so let's say there's a dot here, yeah, indicating that, oh, there is something already occupying this space, and we are coming down. So what we're doing is, if we are here, we are doing a plus width. So plus width would be, the width is presently 4, which is going to be 1, 2, 3, 4, right? So if we are detecting that at this place there is a dot, then we need to go back to the top. That's what we are doing here. Let me reiterate again. Imagine we are at 4, right? We're at 4, and then there is something at 8, right? So all we have to do is go 4 steps ahead, or go 1 grid line ahead, which is your grid width essentially. So we're going to the next line. We are checking out, is there something on the next line? Is there something on the next line? So that's what we are checking for. Is there something on the next line? If something is on the next line, then let's go back to the top. How do we check for something on the next line? We will just take our present position and add it to the grid width, which gives us the next line. Simple. Okay, so that's what this is doing. Okay, fantastic. Yeah, and that should work. Let's see that in action. Okay, we start. Okay, goes down, goes down, goes down, starts again, goes down, stops, start. Yay! See. All right, I hope you understood how that is working. Yeah, okay, good. Yeah, now that we have our shapes stacking on each other, the next thing we want to do is we want to make sure that when we press a button, it goes to the left or it goes to the right. So when we press left, it goes to the left, and when it goes right, it goes to the right. It isn't something complicated. It's something a bit straightforward. And what we're going to be doing is we're going to be making use of an event listener, and this event listener is going to be on the Windows object. That's where it's going to be. That's where the event listener is going to be. So we're going to say window dot add event listener. Then what we want to listen to is a key press. This is very important because it's the key press that would give us access to, the key that we are using. Okay. Then we have if e.key is equal to a d, a small d. You could make it a capital D too. So you could also say if e.key is equal to a small d, or if e.key is equal to a capital D. You could do that too. So we're going to say move to the right. We haven't created this function yet, but we are going to create that right away. So that's what we're going to do. So where should we put it? We'll put it here. Okay, so we'll say function move to the right, and then what we are going to do here is similar to what we did here. Remember, we are just changing what the shape looks like, where the present shape is. Remember, the present shape has numbers that are kind of the coordinates or where it is on the board. So I'm going to say present shape is equal to present shape dot map, and then would say position, and then would say position plus 1. So what we are doing is if we have 0, 1, 4, 5, we are moving it to the right. That's going to give us 1, 2, 5, 6. If that makes sense. Okay. Yeah, so let's look at how that would be. Save. So you can see if we press D, it goes to the left. It's a bit funky, but we'll correct that. So why is that happening? That's because here we are moving the shape to the next level before filling the board. So let's just take this to the top, save, and then if we go back, see? Yeah, but as we can see, if we move, it's still moving outside. It's still moving. Okay, let me refresh. Okay, so now let's say I press it too fast. You can see it's going out of bound, and that's not what we want. So let's prevent it going out of bound, right? That's also kind of simple too. Sure, somebody somewhere will be like, yeah, you keep saying it's simple, but it's not. Okay, so we're just going to do this. So I just can say prevent the shape from going overboard. Okay, I'm gonna say for let I equal to 1. I is less than the grid height I plus plus. So here we want to get everything. So okay, let's go back here. So what we want to do is get, remember we got all the last line. What we want to do is get everything at this, all the index for, not all, but at every point in time, we want to get what is the extreme right. What is the extreme right? What is the extreme right? What is the extreme right? At every level we are in, we want to find out what is the extreme right. If we are at the extreme right, then we shouldn't go overboard. I hope that makes sense. Okay, so let's move to the right. Okay, so yeah, so we're going to say const extreme right is equal to I multiplied by the grid width minus 1. Okay, so initially I is 1, so that's going to be 1 times the grid width, which is 4 minus 1. Okay, that makes sense. For the first line, the extreme is 3. So if we say I multiplied by grid width, which is, that's 1 times 4, that is the first line. So that's 1 times 4. So that's going to be 1 times 4 minus 3. 1 times 4 minus 1, right? So this is going to give us 3. So if we on the next level, which is going to be 2 times grid width, which is going to be 2 times 4, which is going to be 8. So that's 8 minus 1, which is going to give us 7. Remember 0, 1, 2, 3, 4, 5, 6, 7. All right. So if we have 3 times 4, which is going to give us 12, 12 minus 1 is going to give us 11. Yeah. So that's how we are going to get the extreme right. Okay, so back here. So we'll just say we're going to stop the movement if the shape is at the extreme. Right. No, back right. Okay, so if present shape dot includes, now this should be familiar. Okay, so remember the other time we were using the last board, so it's kind of like the same thing. So if present shape dot includes extreme right, so if the extreme right, like if it's so let's imagine the extreme right presently is what's it called, is 3. So if when we're moving the present shape, one of the coordinates has 3 in it, then it means that we are at the extreme right. So remember, as we're pressing right, the coordinate is going to be moving from 0, 1 to 1, 2 to 2, 3. So immediately we have 2, 3, and then the extreme right for that particular place is 3, then go back. Don't do anything. So let's try that out. So now, see, I'm pressing and it's not going. So yeah, so we've been able to do that now. See, it stacks. Whee! Yeah. Fantastic. Oh no, not you. Okay. At the moment, if we move, let's say for example, there are so many boxes stacked on each other, we would still be able to enter into that box. Okay, so let's go back. Okay, let's refresh. So now I've moved to the right. If I move to the right again, and I move to the right, so now if it comes down, if I move to the right, it's going to still enter. That's not what we want. We don't want it. We don't want the shape to go into each other. We don't want the shapes to go into each other on the board. That's not what we want. So we want to prevent that from happening. That's also, not difficult to do, honestly. That's simple. Okay, so let's go back here. So I'll move to the right. So we're going to say we want to prevent the shapes from entering each other. So we'll just say if present shape dot sum. Okay, this is different. We've been using dot includes. Now we're doing sum. Okay, so we're just essentially saying if at least one of this. Okay. If sum, let me say position here. Okay. So board position plus 1 and equal to dot. Okay, and we'll return. All right. Okay, so what I'm saying is, remember, it's similar to when we were trying to detect if there was something at the next level, which is, where's that line? This place. Remember when we're doing this, just look at this and look at this too. They kind of look alike. Just look at two of them, right? So remember here, we were checking for what's on the next line. Remember, that's what we're doing. So for this one, we're not checking for what's on the next line. We are checking with what's in the next column. So remember, this is one column, one column, one column. So we're asking ourselves, okay, so is there something here? Like, let's say, for example, we are here. Let's say we are here. Let's say we're here, for example. We're asking, is there something here? Is there something at the moment that is here? So if we have like a dot here or a dot here, we are checking with +1. We're checking, is there something here? If something is here, then don't do anything. That's essentially what we're doing with no. So that's what we're doing here. So we're checking, is there something at +1? Okay, if something's at +1, don't do anything. Okay, so let's try that in action. I'm saving, going back. All right, refreshes, goes down, then goes down, then goes down. So now we're going to let this, so I'm pressing so hard, nothing's happening. It just works. It just works. Fantastic. Yeah. Okay. Now we could easily replicate this for moving to the left. So for moving to the left, remember, so for left, that's going to be A. So I will just duplicate this and say A. And instead of move to the left. And then we're just going to duplicate this. So copy, paste, right? So we want to essentially do the same thing. So let's start with moving. Okay, let's comment all this out first, just so that we have fun, right? So instead of +1 here, we're just going to say -1, right? So if we go back and it refreshes, what's happening? Did I break something? Oh, okay. This is supposed to be left. My bad. Okay, so let's go back. Okay, so now left, right. Yeah. Okay, you can see when we go to the left, it still goes overboard, but at least now you could see it's going to left or right. Right. That works. So of course, let's uncomment this out and then change all the necessary variables. This is going to be -1. And then this part is, instead of -1, it's going to be minus grid width. So we are trying to calculate for, remember for the other one, we're calculating for this side. But this time we're saying we want to get here. So obviously if you do minus grid width, it's just going to come to this side. Yeah, so instead of 1, we're minusing 4. Okay, and let's try that out. Refresh, left. I'm hitting right at the moment. See, it's not going. So see, and they don't enter each other. Fantastic. Okay, now that we have that out of the way, the next thing we want to do is we want to clear a line whenever it's full. So whenever a level is full, we want to clear it. The boxes shouldn't stack on each other forever. So clearing a line is essentially what is called Tetris. Yay! Okay, so to do that, we are going to create a new function, and we're going to call this function clear full level. So function clear full level. Okay, so we're going to call this I'm going to create an empty array, and it's going to be called let field boxes. So essentially what this array is supposed to do is that we are going to loop through the entire board, but not in a linear fashion. It's going to be in a logarithmic fashion, and any line that is full, we are going to put the coordinates inside this box, this array, I mean. So okay, so now let's create the loop to go through the board, but remember, we're not going through it in a linear fashion. So we're going to say for let I equal to 0, I is less than board dot length, I equal to I plus grid width. Then I'm going to say const line length. So that's going to be I plus grid width. All right. So const inner field boxes, so equal to this. Okay, I will explain what this is doing in a sec. So next we're going to loop through the line. We're going to loop through the current line. Okay, because before I even get to that, I'm sure some of you will be wondering, why is this happening? Remember, whenever we get to this part, we're usually saying I++, but you don't always have to do that. You could say I equal to I plus 1 if you want to. So essentially, this is where the magic of jumping ahead. So what we want to do is we want to jump. Presently is 4. The grid width is 4, so we want to jump 4 steps ahead, which is the magic. So this is why I said we're not going through a linear fashion. It's going to be through a logarithmic fashion. This is what makes it logarithmic. Yeah. Okay. Okay. So now we are going to loop through the particular line we are on. So this puts us on the present line, and now we are about to loop through that line. So what we're going to say is for let j equal to I, then we're going to say while j is less than line length. This is supposed to be length, sorry. Then j plus plus, we want to go through this in a linear fashion. Then we're going to say if board j, is equal to dot, then we want to fill the inner boxes. J. So essentially, every single time we meet a field coordinate or a field box or a field position, then we want to push it into this particular array. Then the next thing we're going to do is that if it is exactly the grid width, so let's say for example we're on a line and presently our width is 4 and we're on a line, and then the 4 of them, so the first one was filled, we put it here. The second one was filled, we put it here. The third one was filled, and the last one was filled, which is 4. So it means that if we see 4 inside this array, it means that the entire row or the entire level is full. Then we need to bring it here. So that's what we want to do next. So we'll just say if all is full, add it to the filled up lines. So yeah, we'll now say if inner field boxes dot length is equal to grid width, then field boxes dot push, then we want to push the inner field boxes. Yeah, remember, the reason why we're doing this is because there could be multiple lines that are full. So every time we meet a full line, every time we meet a line that is full, we put it here and then we push it up here. That's what we are doing. Now that we have been able to successfully find out which lines are full, which is what the field boxes is doing, the next thing we want to do is to actually clear those lines. We need to actually clear those lines. So we're going to use a if statement to do that. So let me leave a comment here, clear the lines if there are more than one line or more than one level that is filled. So we're going to say if field boxes dot length is greater than or equal to grid width, then we want to do something. So if, for example, the grid width is 4, if our field boxes has more than 4 coordinates, remember we're just storing figures inside. If it has more than 4 coordinates, then it means that we found a line that is full. So what we want to do is to remember what we did here is we found out where there were dots. So what we want to do now is just to find those coordinates and then remove the dots. So field boxes dot for each position, and then we say board position equal to an empty dot. So we are essentially clearing the dot that we found here. So that's what we're doing. Okay. So with that, we want to put this. We want to call this. We want to call this here. And then we save and we check it out. I should probably close this. Okay, so yay, and it works. It totally works. The only problem now is let's stack this on each other. Then if we go like this and we come down, you see it actually clears, but you can see it's not going down. So that's the next thing we want to do. We want to make sure it goes down. To make the entire board move down, the entire board has to move down whenever we clear level. So to make the entire board move down, we are going to create a new function here. We're going to create a new function. The function is going to be called move all to the next level. So move all to the next level. Okay. And we are going to pass two things. We are going to pass the scan limit and then the multiplier I'm going to explain what they are, but just know that we're passing two things. I'm going to call this scan limit, and then I'm going to call this a multiplier. Okay, so to move all to the next level, we want to check if we want to look at the line above us. So that's what we're essentially doing is, okay, we've cleared a particular line, then we're looking at the line above us, and then we are bringing it down. That's what we want to do. Okay, so to do that, we're going to say for, okay, let me first put a comment to say check above the line that was cleared. For let I is equal to scan limit. So we're not checking everything. So we need, we're not checking everything. We're not checking the entire board. Yeah, so there has to be a place where we need to start from. We are not starting from the top of the board. We are going to start from somewhere, like so that's what this scan limit is for. So if I is greater than 0, then I minus. So we're starting from the back from. Okay, so let me just briefly, let's just go back to our board. Okay, so if we've cleared this line and we've also cleared this line, if for us to start scanning, we have to start scanning from here upwards. That's what we're doing. So that's why we created this scan limit. So we're going to start scanning from here. So and they will keep counting backwards till we get to 0. I hope that makes sense. Okay, then we're gonna say move the items to the line below. So okay, I'm just gonna say board I plus a little bit of math again. Grid width multiplier equal to board I. Then we're going to say board I equal to I know I have lost some of you there, so let me explain what is happening. So scan limit is the position of the it's essentially the position of the list. Let's say, for example, let's go down here. Okay, so now let's say these two lines are filled, for example. So the scan limit is essentially the list of this place minus 1. We're going to obviously write that, don't worry about it. So what we're doing is we want to start scanning the board from here upwards, which is why we're using minus. Now what the multiplier does is that if, for example, it's only this line that is cleared, then it means that we need to move the entire board one place down. If it is 2 lines that were cleared, it means that we need to move the board 2 levels downwards. Yeah, depending on how many lines were cleared. Okay, so if we go back, Okay, wow, that's a lot. Okay, so now you can see grid width multiplied by, let's say we've cleared 2 lines, that's multiplied by 2. So we're saying that this should go 2 places downwards and then replace it with a dot. So remember, those lines are already cleared, there's nothing there, so we are going to replace it with the dot from above. Then we are going to replace those where we are coming from with an empty dot. So I said an empty dot with an empty string. All right, I hope that makes sense. So if the current level is, let's make it simple. Okay, so let's imagine that we are here, right? This is 0, right? Okay, so we want to move 0 to 4. So what we are doing is we are saying grid width. So let's say we're going 1 level downwards. So grid width is 4. So that's 4 times 1, which is 4, right? Then 4 plus 0, which is, remember we are doing board square bracket I. So board square bracket I plus grid width times multiplier. So here the grid width times multiplier here is 4. So our I is 0. That's 4 plus 0, which is 4, which brings the dot. If there's a dot here, it brings the dot here. Okay, so let's imagine we were here. This is a dot, this is 4, and we want to come here. So we're going to say grid width times multiplier, that is let's say 4 times 1 level, which is 4, plus I, which is 4 here, that is 8. So if we bring, so that will make us go 8, right? If for some reason it's 2, let's say we've cleared both this level and this level, that's 2 levels downwards, right? So we want to move the I from here to here. We're going to say grid width times multiplier. The multiplier here will be 2. So that's 4 times 2, that's 8. 8 plus 4 will give us 12. So presently we're 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll bring our dot to this position. So I hope that made sense. So let me just leave a comment here that says the multiplier determines how low the object would drop. Okay, so now let's create our scan limit and multiplier, right? So we're going to say const calc multiplier is equal to field boxes dot length divided by grid width. So if the field boxes had 4 objects, 4 positions, if we divide it by 4, that is going to give us 1. That's 4 divided by 4 is going to give us 1, which means we are going 1 level downwards. If it's 8, it means 8 divided by 4, which is 2, which brings us 2 levels downwards. So yeah, so then the multiplier is going to be equal to calc multiplier is greater than if. So okay, so sorry, let me restart this. I want this to make sense. So if, okay, calc multiplier is greater than 0, then we bring back calc multiplier, else we just return 1. Yeah, so const scan limit. So remember, scan limit is just where we should start checking for, we're not checking the entire board. It doesn't make sense to check the entire board. So we're just going to say math.mean. Then we're just going to spread the filled boxes inside. Remember, filled boxes just have numbers in it. Then we're going to subtract that with 1. So if for some reason let's go back to the top. Okay, so if for example we are here, which this is 4, so what we're saying is, remember, we have scanned this entire line and we have filled the filled boxes with this. So presently filled boxes will have 4, 5, 6, 7. So we're picking the least number, which is 4. Then we'll minus it by 1, which means that we want to start scanning the board from 3. Then to scan from 3 to 1. Yeah. Okay. Yeah, then with that, we just say move to the next level, move all to the next level, and then we pass our scan limit and then our multiplier. And then, yeah, so let's check that out. Okay. All right, it goes down. I want it to stack. Then I'm going to move it to, yeah. See, and that works. Yay. Woo. I feel like that was a lot for some people to take in. Yeah, so that was nice. Woo. To be sincere, I think we are done with the game. At least we are done with all the mechanics for the game. What's left is just for us to generate scores and then probably just improve the animation. That's essentially all. So in order to generate a score, let's first go back to our HTML, our index.html. Then inside here, we're just going to create a h3, and I'm going to write score, and then I'm going to create a span, and this span I'm going to give it an ID, and I'm going to say score display, and here I'm just going to put a 0, right? Yeah, so that's all for the HTML. Next, we want to, let me copy this. So next, back in our main.js at the top, we are going to bring this in. We're going to say const score display is equal to document dot get element by ID. That. Then we're also going to create a what's it called? A variable called score. And that's going to be 0. So let's see how that looks like. Okay, so fantastic. Okay. Okay, so in order to generate our score, we're just going to create a new function. We're going to call this function add to score, because a score exists and we just want to add to that score. So add to score, and then I'm going to say score plus equal to 50, and then I'm going to say score display dot text content is equal to score, and I'm just going to carry this and paste it here and save. Simple enough. So that comes down, and yay, we have 50. But what I want to do, this works fantastic. What I want to do is that if more than one level is cleared, then I want the score to be let's say it is 2 lines that were cleared, then I want double the score, and so on and so forth. So if it's 3 lines, triple the score. So in order to do that, what we have to simply do is put in multiplier here, right? Remember, multiplier is either going to be 2, 3, 4, 5, depending on how many number of lines were cleared. And then here, I'm going to bring in multiplier again. And instead of hard coding this, I'm going to create a new variable called present score. That's going to be 50 multiplied by multiplier. You could also do that here too, but I just want it to be on a separate line. And I'm going to say present score. So I could leave a comment here and just say gives more points when more levels are cleared. Okay, so let's see that in action. Yeah. So instead of 50, we have 100. Fantastic. So yeah, we've been able to add scores. We have only been using cube, like the cube, for the shapes so far. We need to add more shapes because we can't, what is Tetris if it's just one shape? So what we're going to do is we're going to add more shapes. So we will just go straight to the shapes. Remember, we created this earlier, right? So first off, we don't want to hard code this any longer. So we're going to replace this 4 with grid width. And then we're going to replace this with grid width plus 1. Okay, remember, we're starting out from 0, 1. So now grid width is 4, which means that it's going to come here. If for some reason you have an additional column, and that means your grid width will now be 5, it means at the end of the day, this will still end up being 5, and 5 will be here. If it's 6, this will end up being 6, and 6 will be here. So it doesn't change shape. The reason why we're doing it like this now is the cube remains a cube no matter how many columns you add. If you don't do it like this, the moment you add an additional column, it's going to break. Another thing I want you to notice, that the reason why we're just saying grid and grid width plus 1 is because we're starting from 0, 1. If you're starting from, example, like the top of your cube is 1, 2, like this, so that means you want to start 1, 2 like this, please do this with plus 1 and do plus 2 here. All right. Okay, so now let's create the straight determiner. I don't know what it's called, but I'm just gonna call it straight. Then I'm going to say 3 because I want it to start from here, right? 3 grid width plus 3. This 3 is just like you're saying directly under it. So if this is 2, make sure you put 2 here. So then we're going to say grid width multiplied by 2 plus 3, and then we're going to say grid width times 3 plus 3, right? So here we're going to come and add straight. So if we want to use this straight, just change this to 1. And if we save and we go back, so see, so you can see it's a straight determiner. Yay! Fantastic. Let's now create a function that is going to essentially just be changing this index. Yeah, okay. So which is going to kind of like change the shapes to become random. So we're just going to call that random shape picker, and Let me just create that at the base, or I don't know. I don't feel like going too far off. Let me just do that right here. So I'm just going to say function and call it random shape picker. And then we're just changing the shape index. We're going to say shape index is equal to math.floor math.random multiplied by shape picker.length. So essentially what this is doing is we want to pick whether it's 0 or 1. That's what we're doing here. Then we're saying present shape is equal to doing essentially the same thing. Let's copy everything and paste. So this changes that. Then the next thing we need to do is we need to call it at different places. So the first place we want to call it is that, remember, whenever you get to the base of your board, another shape pops up at the top. So that's the first place we want to put that. Where's that? I think is it move all to the next level? Okay. No, is it move? Is it move? No, not move all. Is move shape down? Oh god. Okay, yeah, found it. So instead of this line, we paste this here. I know our code is getting pretty long. We might probably just rearrange everything into different models at the end, but for now just bear with me. Just bear with me. The second place we would like to put this function is going to be at the initial start of our game. So here, just right here after this. So what we're doing is that at the beginning of the game, it's just going to pick a random shape, and it could either be the cube or the straight tetraeder. So yeah, that's how we randomize the shapes that we put on the board. With those in place, then it's time for us to make the game come to an end. I mean, that should make sense. So the next thing, so we'll just create a function called check for game end. I know our code is getting pretty long. We might organize it into modules. Who knows? So function. I feel like this video is getting very long, so I'm just going to call this function for check for game end. So what we want to do is we want to, how we checked for if we are at the base of the game, we want to check if we are at the top of the game. So we're going to create a variable. We're going to say const top board line. Then you can decide to hard code it. You could do 1, 2, 3, 4, but I mean, hard coding it, if your column expands, then it means that something might break. So we're going to say we're going to create a for loop. I'm going to say for let I equal to 0, I is less than grid width. I mean, of course, I plus plus. So we're just essentially going to fill the top board line with it. So that's top board line dot push I. With that, we have the top of the board. Okay, so to check if we're there, we're just going to say top board line dot for each, then position. Then we are going to check if that part of the board has a dot. So we're going to say board into bracket position. So if board position equals to a dot. So if there's a dot, it means that that part of the body is filled. So all we have to do is cancel the interval. So we're just going to call this const. We're going to call this game interval ID, and then we're just going to say cancel Lord, can't spell today. Clear, I say cancel, clear interval, sorry. And then we're going to say game interval ID. Okay. Why is this? Okay, so with that, we also want to quickly create another element here. Put this h2. I'm going to call this end display. I wasn't planning to do this before, but oh well. So copy, save back here, and then we'll say document the get element by ID. This paste the text content equal to game over. So we save. And let's try it out. Fingers crossed it works. Okay. If we do, okay, it didn't work. Okay. Oh, of course it wouldn't work. We are not calling it anywhere. Sorry, my bad. So we're gonna call this after move shape to the next level. Yes. So we'll call it here. So let's go back and try it again. Save. Drop. Oh, you can see the random is already working. You can see it randomly picked that. Woo, fantastic. Okay, drop game over. Woo, yeah. Okay, so that works, and yay, glad about that. Now I want to make the animation smooth, and this is going to introduce us to something in JavaScript called request animation frame. Of course, we could use set interval like we have been using before, but I feel like using request animation frame is better than using set interval. Yeah, I mean, that's why request animation frame was created. So we're just going to learn a simple way of creating. So instead of where's that set interval here, so we're going to replace this. Okay, so first thing we want to do is we want to create a function. We're going to call this start animating, or start animation. I think that's better. So this is going to have a variable called FPS representing frame per second. So if you know anything about animation or video creation in general, you would have heard things like 30 FPS, 60 FPS. So now I'm going to create like variables above it. Normally this should have been at the top of our of this code, but when I'm getting quite lazy, so I'm going to say FPS interval. Then I'm going to say initial time. In initial time. Yeah, I think that covers it. So next we're going to see FPS interval is 1000. So this is 1000 milliseconds. Remember, this is 1000. So we're going to divide it based on the FPS. So if we pass into, so this is going to automatically drop to 500, which is going to give us which is going to be like how quickly we want it to change. So obviously if this is 500, this will be faster. So you kind of get the picture. Okay, So we have initial time is equal to date dot now. Then we're going to create a new function. I'm just going to call it game animation. I'm going to call the function here. So that's game animation. Whew. Then I'm going to bring in request animation frame. So whenever we call this and request animation frame is called, what request animation frame will do is paint the screen once. But in order to have that continuous painting, we need to pass in this function again. So yeah, so we have game animation. So it's kind of like an endless loop. I mean, even set interval is like is endless. Yeah. So it's just going to keep calling itself. Then this returns an ID just like set interval. So we're going to call this okay, so I'm just going to put animation ID here too. Animation ID. So I'm going to say animation ID, yeah, is equal to that. Then because request animation frame is very fast, we need to kind of, I won't say break how it calls itself. So we have to kind of delay the next painting. So it matches this whole FPS thing that we're doing. The reason why we're doing all this is so that it's not so fast. It paints depending on what FPS we want. Okay, in order to do that, that's pretty simple. We'll just say const now is equal to date dot now. Then we say const elapsed is equal to now minus initial time. So that gives us the distance of when was the last time we painted. And then we'll say if elapsed is greater than FPS interval, then we want to now do everything we have been doing in our set amount. We'll just do this, cut, paste it in here. Para. We can now ignore you. Bye. Okay. So, but this isn't enough. This will draw, but I mean, it wouldn't tell us when is the next frame. So what we have to do is we now need to update the initial time. Remember, the initial time was done here, so we need to update it. We'll say initial time is equal to now minus elapsed modulus this. So that updates our initial time. So all we have to do is do animation, start animation, then we pass in how fast or how slow. So if we pass in just 1, that's going to be 1000 milliseconds, because I mean 1000 divided by 1 is 1000. So that's just going to look exactly like it looked before. You can see it just looks like that. But if we increase it to, let's say 2, you see it's going to be much faster. Can you see it's dropping quickly? So yeah, so instead of using set interval, I think I would encourage you to explore request animation frame. Yeah, that's good. Wow, with that we have come to the end. I think we've covered pretty much everything that has to do with Tetris. Of course, I know we didn't do the whole rotate, the shape, whatnot, but I think with this we have a solid grasp of creating Tetris, and I think it's something you could continue on your own. If you watched this so far, thank you so much. I would have loved to divide the functions into different modules, but I think the video has gotten pretty long. But if you really like it to be very long like this, just let me know, so maybe I'll just finish everything. Also, if you would like me to do this in either React or Vue, Do let me know. Or if you even want me to do it in React Native, do let me know. I would love to do that, but just let me know if you want it. If you have any other question, please let me know in the comment section. The code to this should be also in the description, and if you are not yet subscribed, please do subscribe. Give me a like if you like this video. Thank you so much for being here to the end. You have been a great Charles Angel. To the next video, I'm hoping to do more 999 in one game, so just stick around. We're going to be doing really great videos are coming up. Yeah, okay, thank you for sticking to the end. Till the next video, bye.